Now we're going to look at symmetry. There are two types of symmetry, even and odd. Even symmetry is when a function is symmetrical about the y-axis, or when f of x, or the the output from x, equals the output of negative x. So you'll have the same output, or y values, for x and negative x values. So what we'll see here is a quadratic function, which is the same for the x values as it is for the negative x values. We'll have the same y value for the x value and the negative x value. So for example, say you put in 2, your output may be 5 here. You put in negative 2, your y value may also be 5 here, and therefore the function is therefore even. A function is odd when it is symmetrical about the origin, or when the negative x values equals the x values made negative. So we see here we have an odd function because it's symmetrical about the origin. To calculate this, we're going to change the signs of x in the equation. So here we have f of x, just our normal equation. These are the normal x values, and which we're going to see if it is the same of f of negative x. So what we see here is negative x cubed is just going to become negative x. However, here you get negative x squared, which becomes a positive. So now we have positive 2x squared. Here we have minus 2 times negative x, which now becomes a positive 2x, and which we see here in the original f of x. That is, there's a difference, and therefore we can already tell before going any further that f of x does not equal f of negative x. Therefore the equation is not even. So now that we have, this is what f of negative x looks like, we're going to try to find negative f of x. So here we're going to have x cubed then made negative. We're going to have 2 times x squared then made negative, and then we're going to have negative 2 times x then made negative, and the same throughout the whole equation. What we're left with is negative x cubed minus 2x squared plus 2x plus 8 over negative 2x squared plus 3x minus 10. And if we look back to f of negative x, here we have the same sign. Here, we already have a different sign. And there we can already tell that f of negative x does not equal negative f of x, or that our equation is not odd or even by looking back at this. So here I have a little sketch of my function, and we can tell visually by looking at the graph that the function is neither odd or even. This is the algebraic calculation. However, if we look, my positive x values will not equal my negative x values. As you see, if I flip this over the y-axis, I do not have a reflected image over the y-axis. Same with the origin. If I were to turn my paper around, this does not look like the same as this. Therefore, we can tell that my function is neither odd nor even.